Good afternoon, all. In the previous sessions, we have completed half of the module 3. We have seen about the antennas, basic antenna parameters, some of the problems, some of the concepts we have seen. The other half of the module, let's start. It starts with the strip lines. Okay, strip is a very general word which you might have come across in your day-to-day lives. Strip, okay, a long strip. You can even imagine what is a strip. Okay, a long wire kind of thing. So strip lines. So before going for this further into the details of the strip lines, you should know the basics of what is a transmission line. Okay, so when you hear this word transmission line, what comes to your mind? Please interact, we can have a discussion. What is a ट्रांसमिशन लाइन? जब आपको ये सुनाई देगा वर्ड ट्रांसमिशन लाइन, क्या माइंड में आता है आपके? Zubair, I should now point everybody's name and ask the questions.
Yes, ma'am.
हाँ जुबैर, what is a transmission line? ट्रांसमिशन लाइन जब वर्ड आता है दिमाग में क्या आता है?
Ma'am, it is a path which is used to send the messages.
हाँ, path, the
Which
medium.
converts electrical
Yes.
to voice.
यस, वेरी गुड. आप इंफॉर्मेशन थियरी में भी आप पढ़े हो, राइट? आईटीसी में चैनल्स के
Yes,
बारे में
ma'am.
पढ़े होंगे आप. Basically, you might have studied about the encoding, what is the steps followed, and why we go for encryptions, and you might have studied across ITC regarding the channels. So a medium for communication is a transmission line. Okay, when you come across these mediums, when the antennas, that's why this topic has been inculcated in your syllabus. It is a part of your communication. In the previous thing concept, you have studied about the antennas. Okay, transmitter, receiver, the parameters, basic parameters we have studied, and we know the basics of how the communication gets established. Transmitter, receiver, the waves will be traveled through a medium, and then they'll get received. So this medium is very important. Okay, if in case of your mobile phone, air is a medium. Okay, but when you're coming across the devices, when you're using this medium, there are many concepts, many many things to be taken into account. Very important is losses. Okay, in practice 100% efficient system you cannot achieve. So obviously there will be having certain losses. So keeping that into mind, so how we define a transmission line in general, and how we achieve to come to the strip lines. So we will see that. Okay, now we will start with the transmission line. Transmission lines are actually what? They are conductors serving as a path for sending the waves, or waves, electromagnetic waves. They carry the energy. So you transmit the waves, you transmit the energy, power through them. So it's like a medium. They form the connection between the transmitter and the receiver for signal transmission or signal reception, whatever. uh, it is used to convey the radio frequency power from the transmitter to the antenna, and from the antenna to the receiver, on both sides. Okay, if you consider only the transmitter part, it is the first half. If you consider the receiver, it is the second half, from the antenna to the receiver. So generally, a transmission line is a structure which is designed to carry the energy from one point to the another point in general. Okay, we will see what is this broader classification of transmission lines, how the transmission lines are classified, because we should now see where this strip lines fall. We will see where it falls. Transmission lines, they are broadly classified into all these categories. You can see open wire transmission line, coaxial transmission line, optical fiber, then waveguide, it is also a type of transmission line, and finally microstrip line. the heading which you are going to learn, that strip lines, it falls under this category. Okay, in your throughout your engineering, I think in this semester you'll be studying about the waveguides and this micro strips. These are the open wire is a obsolete one, still used sometimes. Oh, optical fiber, you'll be studying it in your 8th semester. So the transmission line concept is very important. How you might have even seen how this geofiber cables are, they're laying the cables, they're laying the cables even under the underwater seas. That's why this geo, it has a widespread network. Because of that, it has become cheaper also, right? So you'll be studying across about these transmission lines in detail. In this the microwave and antennas, you'll be studying about these two. In your 8th semester, you'll be studying about the optical fiber. I think FON, fiber optic networks. You'll be studying the subject. Now, I have just here pasted few pictures. You can see what is this open wire. I think this is a very familiar photo which you might have seen from your childhood when you cross the roads, right? Open wire. Mostly, it's a very old traditional method of communication. Open wire transmission line. And you can see here open wire. Then this is also open wire, okay, pair of. This is also, अगर आपके घर में पहले CRT मॉनिटर था, टीवी टेलीविजन्स, उस टाइम पे उस CRT मॉनिटर को ऐसा केबल आता था. प्लीज ट्राई टू रिकॉल, आप बहुत छोटे थे तब. During that time, these kind of cables used to be to your to be connected to your television sets earlier. Now you can see these are some of the open wire transmission line examples. The second one here, you can see it's a coaxial cable. I think television sets पे ये आते हैं आपके जो केबल टीवी कनेक्शंस आते हैं, शायद ऐसा ही होता है वो केबल कनेक्शंस. I think even in your lab experiments you have used this kind of cables. Have you used this kind of cable anywhere? Coaxial cable you have not used? I think many of you have done some mini projects. You might have done some of the experiments in your analog lab. You might have come across this kind of cable. जब आप ऑडियो सिग्नल जनरेटर एंड CRO को आप कनेक्ट करते हो, कनेक्शंस लगाते हो, ऐसा केबल यूज किए हैं आप?
Yes,
Yes,
ma'am.
ma'am.
Yeah, you might have used this.
Yes, ma'am.
Yeah, this is second type of cable. Earlier, prior to whatever the optical fibers and all, this was the most famous, most reliable coaxial cable transmission line. Most reliable earlier. Yeah, the internal structure just I have shown you here. It has got like two in concentric spheres inside the cylinders. The structure looks like this. अब आप काट के देख सकते हो केबल में क्या होता है. This is the picture image of optical fibers. शायद आपने ये भी देखा होगा optical fibers, how they look like. Colorful रहते हैं. This image, actually these images are very colorful, but I have taken the black and white print. I can send these images to on your WhatsApp also. You can see, you can visualize how they look like. Different color cables रहते हैं अंदर, जो छोटे छोटे wires हैं दिख रहे हैं आपको, ये सब अलग color के transparent रहते हैं. Okay, optical fiber. You might have studied about this TIR, total internal reflection, which is the basis of the optical fiber communication. Reflection जो होते हैं, total internal reflection. So they'll be transparent in nature. That is about optical fiber. This image is about optical fiber. Now, here you can see this is the image of waveguides. Even in your labs, जब आप college offline हो जाएगा, when you start attending the classes, you can visit your analog lab. जब आप लैब जाते रहेंगे, कुछ कबर्ड्स हैं वहां पे, ओके, the modular cupboards are there. You can view these apparatus. ये वहां पे हैं, these kind of apparatus, they are available in your labs. You can have a look. They are called by different names, but the general term is a waveguide. Depending on its shape, it is called rectangular waveguide, circular waveguide, depending on the mouth shape. So these are the examples of waveguide. Waveguide, a path which guides the wave. Okay, it is a structure used for microwave communication. You can see these are the strip lines. Okay, some example you can see here. ये जो आपका plate है, it is a very thin plate. Thickness बहुत छोटा है इसका. ये top view है. Okay, it looks something like this, and in between you can see the structure. यहाँ पे कुछ parallel line जा रहा है बीच में. It is what it is etched in the center, and some other strip has been joined here, and through which something is passing, some opening, and the feeding lines are there, opening and end lines. So this is the practical view of your strip lines. They look like this. And how this concept of strip lines came, for that I have just taken one picture. You can see this is your coaxial cable. Okay, two concentric cylinders रहते हैं. The inner has certain radius, outer has certain radius, insulation रहता है. This is one structure of a coaxial cable. How the evolution took place, this circular face, the circular structure, it got to a square structure, both inside and outside. The two concentric materials, they were earlier in the coaxial cable, they were circular in nature, then they made it square, and then probably a rectangular shape. You can see here inside there is a strip. That's why the term strip. Strip is what? Its thickness is very small, it is long. That is called a strip. Inside the structure, the same thing is built now. So strip line, something looks, it somewhat looks like this. You can see it. A indicates a coaxial line with a round central conductor. This is your coaxial line. B is a square coaxial line. Okay, it is also coaxial cable, but the structure is it's not circular, it is square shape. The third one is rectangular coaxial cable. Then this one is your strip line. Basically the strip line looks like this. Under strip lines, again we have different categories. Depending on that, we'll be getting across different strip lines. This is one example of such strip line. Okay, fine. Now under the transmission lines, obviously whenever some evolution takes place, okay, it is based on what, some disadvantages will lead to the evolution of the newer technologies, right? So in the same is the case with the transmission lines also. When we started with the open wire line, it suffered certain disadvantages, some demerits were there. So as a continuity, we just we kept on inventing the different things, how we can reduce the losses, how we can achieve more efficient transmission. So even in the transmission lines, we have this evolution. At microwave frequencies, the transmission lines, which are actually used to carry the low frequency radio waves to and from the antenna, just like parallel wire lines, that is open wire, जो मैंने आपको first figure दिखाया था, this one. If this structure is used for microwave frequencies, what will happen? They have excessive power losses. That is the reason. For radio frequency, they use this. Okay, some towers will be there. The pillars, the support. Then the wires will be laid parallel to each other. That is how your even KPTCL will work, right? The powers, they'll be supplied. But what happens at the microwave frequencies? At microwave frequency, they have excessive power losses, which is not desirable. Okay, excessive, more than, see, अगर आपके पास 100 कुछ 100 अमाउंट है, उसमें से 50 से ज्यादा जा रहा है, आपके पास बच नहीं रहा है, इट्स ऑफ नो यूज कंटिन्यूइंग द सेम मेथड. So excessive power losses will be there if you use similar kind of open wire or coaxial line, whatever the remaining. So what will happen? So when the attenuation is required, when the lower attenuation means what? The signal strength decreases. So ये जो power losses को अगर हमें कम करना है, so what will happen? The microwaves, they are carried by these metal pipes. They are called waveguides and strip lines. I have shown you the figures. These are the waveguides and these are the strip lines. In order to minimize the power loss, excessive power loss, and lower attenuation, to achieve lower attenuation, we go for these structures. We call them waveguides and strip lines. So you somebody may ask you, okay, generally in communication part, so which transmission line is used for microwaves? So you should not answer open wire or coaxial or optical fiber. You should know, because they'll be having excessive losses if you use them. That's why at microwave frequencies, waveguides and strip lines are preferred. Now, in transmission lines, let us see about these strip lines. I have given the title here, planar transmission lines. T lines indicates transmission lines. Now, why this word planar? Planar means what? You see the structure here, coaxial cable with a circular structure inside. If you see at the end, strip line structure, it is somewhat flat. The plane, it's a planar structure. Because of that, these categories under which strip lines fall, they are called planar transmission lines because of its structure, because of its dimensions. These are the lines with the conductors, in some cases dielectric insulation strips, which are flat. The dimensions are flat, because of which we call them planar transmission lines. They are like ribbon shaped. That's what I said. How you identify a strip? Strip means what? Its thickness will be very small, but it will be long. So ribbon shaped line. They're flat, their dimensions are flat, and it is a ribbon shaped. The thickness is very small. So such kind of lines, transmission lines, are called planar transmission lines. They are used to interconnect the components on printed circuits. Again, we have one more advantage of using these strip lines. Nowadays everything has become what? Miniaturized. हर चीज minute size में कम होता जा रहा है. You have studied, or you're studying, I think, VLSI this time, or probably you have studied it last time only. You know Moore's law. Every 18 months, the size, the number of transistors on a chip, they gets doubled, almost doubled. So we are coming across miniaturization. So we are moreover concentrated on the what printed circuit structures. PCBs पे design कर रहे हैं हम. Okay. So when we are talking about these structures, connecting such minute structures one to the other, you imagine what kind of wires are required. So in order to connect such components on the ICs, imagine IC छोटा रहता है, IC में उतने hundreds, thousands of transistors are there. Inside that, those transistors, how they are getting connected? So in order to interconnect such components, we go for these strip lines. Okay, that is one of the advantage. अब इतना बड़ा केबल लेके एक छोटे से चिप में नहीं बिठा सकते हो. You cannot use the coaxial cable, you cannot use the open wires, and you connect inside a chip 1000 transistors, you cannot connect. So that is the advantage. You can connect these strip lines. They are used to interconnect the components on printed circuit boards and the integrated circuits. ICs में interconnect करने के लिए use होता है, working at microwave frequencies. Because the planar of these lines, they fit well with the manufacturing methods of these components. You have studied, you have attended one webinar, right, on 3D printing, I guess, recently. Have you?
Yes, ma'am.
Yeah. What all you have studied there? बेसिकली वहां पे आप क्या सीखे, क्या दिखाए वो 3D प्रिंटिंग में? एनी सर्किट दे शोड यू?
Not circuit, ma'am. He has shown some something he has built on that 3D machine.
हाँ, मशीन पे कुछ कुछ
Like
डिवाइस था।
diva- नहीं वो क्या वो छोटे छोटे ऐसा मतलब टॉयज चीज से वो बनाए से दिखा है मैम, सर्किट वगैरह कुछ नहीं था।
Okay, fine. So you'll be coming across certain kind of machines. You might have heard about CNC machine, mechanical related है CNC machine.
मैम
हाँ, आप उसके बारे में थोड़ा देखो. CNC machine is one machine which is used for manufacturing the components. So under such circumstances, it's the structure of the strip lines, it fits well for manufacturing methods we used for these components. So there is a reason why we are going for this. उसका जो हम manufacturing process है, it fits well for these components, because of which strip lines have been preferably used for microwave frequencies. Okay, so basically there are 4 types of planar transmission lines. Microstrip lines, first category. Second category, parallel strip lines. Third one, coplanar strip lines. And the fourth one, shielded strip lines. So again, transmission lines have some 5 categories. Under that, we have what? Open wire, coaxial, optical fiber, waveguide, and strip lines. Again, in planar transmission lines, we have these 4 categories in general: micro strip, parallel, coplanar, and shielded. So now, one by one, we have the details of all these lines. So first, we will be studying about microstrip lines. So in the microstrip lines, we will be studying about its structure, some of the equations that we come across, what are the different types of losses that, again, as I told you, 100% efficient system we cannot achieve. Again, even these lines will be having certain losses. So we'll try to see what are the different losses associated with microstrip lines. So likewise, all these 4 lines we will be studying in module 3. So I needed some 15 to 20 minutes just to tell you about this is your first topic in your module 3. Directly they have given you microstrip lines as the first topic. But you should know microstrip kahan se aaya, you should know. So we today in the introduction class I have taken about the transmission line, wo wahan se aake yahan judta hai. So in the next class we will be dealing with the microstrip line, one line. So I need another some 4 to 5 classes to complete this. Okay.